a login of some type. So sign in, it's free, and you can go ahead and log in here. It's totally free. And then once you actually log in, you'll come to a screen like this, and I want you to go to create. So create web authoring after you log in. Okay. Should bring you to a sheet here. This is where you load your data set into Tableau. Now, the Tableau data set we'll be using is SOTA Excel. It's an Excel file in your assignments page. So just download that to your computer, and then it says drag and drop here. So it's in my downloads. I'm going to go ahead and drag it in there. It's going to load it, and then your data set's loaded. Okay. So again, what I want you to do, let me just give you a heads up here. What you're going to do here is actually create a Tableau worksheet, okay, that is going to estimate elasticity for specific types of products. And how you're going to turn this in is I'm going to create a quiz that is going to ask you for elasticity metrics, like what did you estimate the elasticity to be, number one. And number two, what's the managerial decision? Increase, decrease prices, and mainly the thing you need to know is why. Again, which effect dominates? Okay, let's go back to the beginning, review that if you need to. But so what we're doing here is we're going to come up with an estimate of elasticity as a first step. So we have SOTA sales. Now, if you look, we have date, city, latitude, longitude, population, shop, brand. So there's different brands of soda in different containers at different capacities, and we have prices and quantities. So this is actual sales data for different types of soda. So how we're going to use this after you load this in Tableau is go to create a sheet. So that's down here. After you load your data, go to sheet, create your sheet. It's going to take it a second. This is on the Tableau server, so it just takes a little bit extra time. But here we go. So once you have your sheet, all of your work will be done in this space. Okay. Now, what we're going to do, it's a little bit of a flip from what you have in your textbook. Remember, in your textbook, we have prices on the y-axis, quantities on the x-axis. In this particular instance, we're going to flip our axes around. So you're going to have quantity on the y-axis, and you're going to have prices on the x-axis, okay? Because we're doing quantity as a function of prices in this case. I'll show you how this all works here in a second. So look, you can really just follow along and do this step by step here. So let's go ahead. First off, we see the date. If you look at date, you might see an ABC next to it. That means that it's recognizing date as a string, meaning a word. We need to change this actually into a date format. So go ahead and click on the arrow next to date, change date type, and we're going to select date. That's a really important step, okay? The next thing is we need to build our axes. So columns, that's going to be our x-axis. Rows are going to be our y-axis. So again, I said we need to have prices on the x. So go ahead and take price over on the left and just hold it and drag it and drop it in the columns. Okay. Now here's a critical point. What Tableau is doing is it's adding up all the prices in the whole data set. That doesn't really make a lot of sense when you think about it, because if you have more sales, then this number increases, but we don't really care. That's not really reflective of price. Do you really think it's 9,000 euros for a soda? No, it does. It's ridiculous. What we need to actually convert this to is an average. So to do that, hover over the arrow on price, go to measure, select average. Okay. Now that looks more like the price of a soda. Okay, that looks a little better. Okay, so we have this on the x-axis. Now we need the y-axis. So go grab quantities, drag it to the rows. Now we have quantity on the y, average price on the x. That looks good. All we have is a single data point. Why? Because, again, this is looking at the whole data set, and it's just giving us a single number. So we need to put the variation in here. The variation that we're going to be putting in is going to be so this varies by date and across brands and other things. But we're going to actually go take date. So take date, and to show the variation, you're going to need to drag date onto the details tab. And you'll see a couple little, okay, so we got a few more dots. There's a weird quirk in Tableau that you need to be aware of, and that's that. So you need to go over to the marks section and click on the arrow for the date pill, and I'm not sure if that's in your guys' way. It's in my way. I'm not sure if you can see that little thing I moved there. But go ahead and click on that little arrow, and you'll notice that we have year, quarter, month, and then we see year, quarter, month again. Well, these are a little different. Like year is 2015. Years, that looks the same. Quarter is Q2. Quarter here is quarter and year. So actually, if you go by quarter, say for instance like this, then you'll get 4 dots. That's one for every single quarter. What it's doing is it's looking over all the quarters. We don't want to do it that way. We want to come down to this below that bar, and it's actually going to be month. So select month where it says month, and then there's a year next to it. Select that. Okay, now we have some variation. It doesn't really look like there's a lot of pattern here. Why? Well, part of it is because we're looking over all the different brands and all the different containers, and this is kind of a scattered mess. So, what we can do is actually look at a specific brand and at a specific container type using the filter. You can do it a couple ways. Use the filter. There's a couple ways to do this, but we can just do the filter way here, and I'll show you. So go ahead and take brand and drag it in the filter. Okay, and you'll see that there's different brands: Adult Cola, Gazoza, Kinder Cola, Lemon Boost, Orange Power. So what I'm going to do for your project and for your quiz, you're going to build this little toolkit in Tableau Public, and the question is going to go something like this. For a specific price and quantity, I'll give you those numbers. I'll say, should you raise or lower it for a specific product? Okay, so I'll say, for instance, Orange Power cans in a certain city. Like you'll see that these are all sold in different cities. So I'll have to give you a city, a product, and a container type. So you have to filter on all 3 of those. Here we're on brands. So say I said Lemon Boost was the product that was in the problem. And let's say I said cans. That'll be under container. So go ahead and take container in the filter. And let's say cans. Okay, these are cans of soda, not glasses. Make sure only one of the boxes is checked. Okay, you have to make sure just the right one is checked. And when you change between problems, you're going to need to uncheck and recheck to make sure you don't have multiple, and make sure you get the right answer. Okay, so here I have cans of Lemon Boost, and these are across all the different cities. So again, I'll tell you the specific marketplace that we're interested in. And in this case, let's go ahead and take city, drag it in the filter, and we have all the different cities in this data set. Let's go ahead and look in Athens. How's that? Okay. Now we're getting something that looks more like a meaningful downward relationship. Okay, so we have this downward scattered relationship. It looks like there's this negative relationship between price and quantity. That looks fine. Again, the specifics of what we've done here is we've plotted price and quantity. We've filtered on city, container, and brand. And that defines our marketplace. Okay, that's really important that you carefully do this. We have prices as average, dates have been set appropriately, everything looks good. Now, how do you get a demand curve out of this? Well, to get a demand curve out of this, go to Analytics, and then you're going to go Trend Line. When I double click on Trend Line, voila. Now we have something that looks kind of like a demand curve, except the axes are flipped. And so technically this is actually called a price response function. Okay, so this price response function, it actually, look, when you hover over it, because you see quantity is Y, average price is on X. If I hover over the line, it'll give me the equation of the line. Here you see reading from the very top right there, quantity is equal to negative 94,735.5 times that this is y is equal to m. M is our slope. Our slope is the first number there, times x. X in this case is average price, plus b, that's our intercept. This is the equation of a line. Y is equal to mx plus b, where this first number is the slope, okay? And that's going to be the key for you to answer this question. Okay, so let me just do a question for you real quick. If I were to say that the price of the price of Lemon Boost cans in Athens, so I have to give you, so if I said the price is equal to 0.5 euros, okay, and at that price, you're currently selling 50,000. Okay, 50,000. Why am I giving you this? Okay, because so in a real business context, the prices that you're selling at, how much you're actually selling. And the question is, should I raise or lower my price? Okay, so I'm giving you these prices in real practice, like that's known information. The question is what to do. Okay, so real quickly, I'll show you. If you remember midpoint method, actually, I'll instead of doing the derivation right now, which will just take more time, I'm going to give you the formula, okay? So the formula for estimating elasticity is going to be the slope of the regression line times the price over the quantity I'm going to give you this information, okay? Like I said, in this example, price is 0.5 euros, quantity is 50,000. I'll give you that. I'll also give you the market. So I'll say cans of Lemon Boost in Athens or in Petra or some other marketplace. You mix your filters to do that, okay? Then you need to rely on this equation to estimate elasticity. In this case, my elasticity, so I take the slope, that's 94,735, and don't round just yet, put the decimal in there, 0.5. That's my slope, okay? Times price, 0.5 over quantity I said was 50K. 50K. That's really, I've been out of space. Sorry about that. So go ahead and let's put this in our calculator. So I'll just go over here to my handy dandy calculator right there, my calculator app. And I'll put in the slope of my regression line, which again was 94,735.5 times my price of 0.5 euros divided by my quantity, 50,000. That equals, okay, 0.95, okay? That's really close to 1. Actually, it's a little too close to 1. I would have liked it. I'll cook it up so it's a little bit farther from 1, but that's really close to being unit elastic, actually. But for this case, and just to be really kind of technical, we'll say that that's less than 1. Okay, so that is going to be inelastic. Now, going back to your equation, it's inelastic. That means that the denominator is bigger than the numerator. That means the price effect is bigger than the quantity effect, which means, again, revenues, prices and quantities are going in opposite directions, but the price effect dominates. So what are you going to do to raise your revenues? You're going to raise your prices. That's the answer. In this case, your answer will be 0.95 as the estimated elasticity, and your answer is you're going to raise your prices because demand is inelastic, and that means that the price effect is going to dominate in terms of your revenues. And again, we're trying to maximize revenues. Let's work out another example real quick. Okay, so what if I said orange So if I said, so you can edit the filter by, if I said a different brand, say, go edit filter. If I said Orange Power, we'll just keep it in Athens. I'm not going to change all these filters. I just show you how to change it once so you can change it. But here I unselected Lemon Boost. Make sure you unselect. I did Orange Power. Okay. I already have my regression line and everything all set up. I'm all ready to go. So let's see. What if I said that the price of Orange Power cans in Athens was 30 cents and the quantity demanded was 100K? So in this example, I'll give you this in the problem. Price is equal to 0.3 euros. I said cents. That's euros. It's in, okay, different. And quantity is equal to 100,000. Okay. You're going to answer this again. Go ahead and try to answer it. Pause the video. Try to answer it. Unpause it after you get an answer and then check yourself, because this is a chance for you to do it without just following. Just try to do it yourself right now. Okay. Price is 30 euros. Quantity is 100,000. This is for Orange Power cans in Athens. Try it yourself. Okay. Here we go. Okay. Hopefully you paused it. Giving you a second to pause it. Now go ahead and unpause it. What you need to remember is coming back to this equation. First step, calculate elasticity. Second step, is it elastic or inelastic? That determines which effect dominates, and that tells you what to do. Okay, so first step, calculate elasticity. Step one. Remember, slope times the price over the quantity is what we're going to do for this elasticity metric. Okay, here's price and quantity. That's what we picked. Slope for this, again, hover over the line. This gives you the equation of the line. The slope is right here. So it's going to be 18, is that 18? No, that's 188,210. Okay, that's the slope, times price over quantity, times P, which is 0.3 over quantity of 100,000. Let's see what we have. Go back to your calculator. Okay. What did I say? 188,210 times 0.3 divided by 100,000 equals 0.56. Okay, it's inelastic again. What does that mean? Again, that means it's less than 1. It's inelastic. That means, again, oops, where's my other sheet? That means price effect dominates. That means the price effect's bigger than the quantity effect. What do? We raise our prices. Okay, because remember, revenues, prices, and quantities going in opposite directions. Price effect dominates. So raise the prices. Okay, let me give you one that's inelastic. We'll just do that one. Let's say that the price, last example, let's go ahead and say the price is 60 cents. Okay, if it's 60 cents, 60.6 euros. Sorry, cents. I'm doing this all day. 0.6 euros, and we'll say quantity is 40K this time. Okay, for Orange Power cans in Athens, I have to give you all that information. So we'll say 0.6. So price is equal to 0.6. Quantity is equal to 40,000. Okay, that's your problem. Calculate it. Pause this. I'll check your answer in 2 seconds. Okay. Okay, unpause. Okay, here we go. First step, calculate elasticity. Determine if it's bigger or less than 1. That will tell you if the price or quantity effect dominates. Here we go. Okay, so remember, it's slope times price over quantity. So highlight your equation, mouse over that, there's your equation. And also ignore the negative sign. Remember, elasticity of demand is always negative for normal types of products. Okay, so here in this case, we have, again, the slope was 188,210. Okay, and it's going to be times 0.6 over 40,000. That's our equation. 188,210 times 0.6 over 40,000. Okay, go ahead. Put it into your calculator. Calculator, here we go. Let's go ahead and clear this out. And it will be 188,210 times 0.6 divided by 40,000 equals 2.82. Okay, now you see that this is actually elastic. Okay, it's elastic. Why? Because elasticity is greater than 1. Elasticity greater than 1 means this fraction is greater than 1. Means quantity effect is now dominating the price effect. It has to be bigger than this for this fraction to be greater than 1, right? Okay, you believe me? So that means quantity effect dominates. Now remember, how are you going to get the quantity to change upward? Because you know that's the dominant effect. How are you going to get quantity effect to change upward just by manipulating your prices? Well, you got to drop your prices, quantity goes out, right? So in this case, the decision is to drop your prices. Why? Because we have elastic demand and the quantity effect dominates. And that is what's going to maximize your revenue. And just in case you're curious, the optimal for revenue purposes only, the optimal elasticity is 1. That's our target. Okay, so at 1, your revenues will be optimized. That is the tutorial video for this particular project. Again, what I'm going to do is I'm going to ask you very specific questions like I just went through in a quiz on Wolfden. And what you're going to do is you're going to go to Tableau Public, you're going to build this tool that I showed you how to build, and you're going to answer the questions on that quiz using this tool. That is the project, and that's how you're going to turn it in. That's the whole assignment, okay? If it's confusing, if you get lost, if you're stuck in any part, please come to my office hours. I will push this out a little bit of time to give you some time to come in and talk to me. But otherwise, I just wish you the best and good luck on this assignment, okay? Okay.